So when we're dealing with data sets, you will come across some circumstances or some instances that there are items in your data set that sometimes belong, and sometimes there's items in your data set that you can figure that don't belong. And in this particular case, we're talking about a data set that is times for running for a sprinter, okay? And the first 5 times you can see that this sprinter came along and his first time was 30. His second time was better, 28. Third time was quite a bit worse there at 36. His fourth time was better again at 32, and then he managed to meet his personal best again at 28, and that was his fifth time. And then all of a sudden on his sixth try, sometime, and this happens sometimes, this sprinter ended up falling, and all of a sudden we have a time of 56, okay? So if we take a look at this data set, we have numbers, the first 5 are all pretty consistent, within a few digits of each other. And then all of a sudden we have a number 56 here that is much larger than the rest of our data set. And this is what we call an outlier. So an outlier is a number in our data set that is either much larger or it could be much smaller than the rest of our data set. Sometimes it's important that we keep the numbers in the data set, and sometimes they need to be removed because they affect the data or the central tendencies too great. Now we're going to take a look at what parts of central tendencies this outlier affects the most. So we're going to calculate the mean. So we will calculate the mean, first of all, with the error, and we'll put that in yellow. So our mean, with the error, we'll add all of the 6 items up in our data set, and if we add 30 plus 28 plus 36 plus 32 plus 28 plus 56, we end up with a number of 210, and we would end up dividing that by 6 to get our mean. And in this case, our mean would be 35, okay? And that is with the error. So that's with the error, and this is, of course, the error is when he fell. And then we're going to take a look at if we were to take that number, the number where he fell, and calculate the mean again. So what we're going to do is we're going to exclude that number 56 from the data set. Okay, so that's going to reduce the number of items in our data set by 1, and it's also going to reduce the total amount when we add them up. So we add 30 plus 28 plus 36 plus 32 plus 28, and we end up with 154. And then we're going to divide that by the number of items in our data set. It's now 5 since we excluded the error. And you can see that our mean then comes out to 30.5, and that's without the error. Okay, so you can see there is a big effect on the mean when we're calculating it with or without the data set, or the outlier, sorry. So let's take a look at the other items of central tendency that we're interested in calculating with and without the outlier to see if it does affect the other central tendency. So let's take a look at the median. And so we know that when we calculate the median, we're going to have to order our data set. Our data set is out of order right now. So let's order our data set to calculate our mean. So we're going to have 28 and 28 and 30 and 32 and 36, and we said this is going to be with the falling time, so we're going to have 56 in there. So in order to calculate the median, we're going to take the middle 2 numbers, which is 30 and 32, and we find the mean of these middle 2 numbers. So that ends up being 30 plus 32, which equals 62, and divide that by 2 and we're going to end up with a mean here of 31, or sorry, a median of 31. So let's take a look and see if we exclude the outlier and see what effect it has on the median. So let's rewrite our data set. We'll rewrite it, and this is excluding the outlier, so we'll rewrite it as 28, 28, 30, 32, and 36. Okay, so now if we take a look at the middle number, there's only one middle number now, so our median in this case ends up being 30, which is pretty close to the median with the outlier included in the other one. So, and one last thing we want to take a look at in our central tendencies is the mode. So we'll try the mode first of all with the falling time included. So here's our data set, and again we're going to include the outlier this time. So we have 28, 28, 30, 32, 36, and 56. And if we take a look at the item that repeats the most or is included in the data set the most, it's 28, it appears twice. So we end up with a mode, in this case, of 28. And we'll take a look at the mode with the outlier taken out. So our data sets end up being 28, 28, 30, 32, 36. And in our data set, we can see, again, it's the two 28s that stand out. They repeat. So we end up with a mode, in that case, of 28. So what we can see is by calculating all of this, and normally you won't be asked to calculate with and without for all 3 or 4 central tendencies, but the central tendency that's most affected by outliers is the mean. And we can see that right here, because with the outlier included, we had a mean of 35, and excluding the outlier, we had a mean of 30.5. So you can see that's the biggest change in central tendency.